Hello my dear friends, let's learn mathematics step by step. In this channel, we started discussing from graph theory. But after completing this course, after they presented the basic concepts and field of graph theory, we will discuss on other parts of mathematics like algebra, mathematics and knowledge, differential equations, general mathematics, and etc. If it is your first time in this channel, it will be very nice. Subscribe to this channel. Thanks for being here. Thanks for your supporting. Let's go on today's topic. Our today's topic, complete bipartite graph. Before to going complete bipartite graph, we have to know what is bipartite graph. As we had discussed in the last video, bipartite graph is a graph to, if we can, the number of vertex of that graph divide into two sets like V1 and V2, such that any elements amount the element of these sets V1 and V2 should not be adjacent. So in here we have a little more different between complete bipartite graph and bipartite graph. Complete bipartite graph, suppose V1 and V2 be bipartite graph if each vertex of V1 is adjacent to each vertex of V2, then the graph is said to be complete bipartite graph. A complete bipartite graph if V1 and V2 they have m and n elements, then we denoted complete bipartite graph by kmn or knm. It means, and here we have a complete bipartite graph such that the two sets divided, two sets, they have one is n element and other one is n elements. Look in this graph. And at this graph, it has 6 vertex, A, B, C, D, E, F. We can divide this, the vertex of this vertex of this graph by V1 and V2, such that V1 is equal A, C, E and V2 is B, D, F. Look in here. Any element of V1 is not adjacent among each others. In here, V is not adjacent to C, and also it is not adjacent to E. So same in V2 we have like this. We can write the A, C, E on one side, and another side we can write B, D, F. It is the element of vertex V1, set of V1, and these are the element of set of V2. So as it is clear, and this graph and the given graph is adjacent to B, to B, to D and to F. We can write A, we can make connect A to B, A to D, A to C. Same, C is also like this, and E is also same to A. These types of graph and the field of graph theory we are calling complete bipartite graph. And the complete bipartite graph, the number of vertices always m plus n. m plus n is always the number of vertex in a bipartite graph. Look in this example. Here m is equal 3 and n is also equal 3. So it means the number of vertices in this graph, it is equal to 3. 3 plus 3 equals 6. The number of vertices in complete bipartite graph, it is m plus n. M is 3, n is 3, 3 plus 3, it is equal 6. It means this complete bipartite graph, it has 6 vertices. 1, 2, 3, 4, 5, 6. And also the number of edges in a complete bipartite graph, it is m times n. M times n. Okay, m is 3, n is 3. 3 times 3, it is equal 9. Okay, if we count the number of edges of this graph has 9 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. It has 9 edges. And also the degree of every vertex in the complete bipartite graph, it is m or n. Look in this graph. Every vertex is degree 3. Degree 3. It is degree 3. And here also same. And one more thing. In the complete bipartite graph, we don't have any isolated vertex. We don't have any isolated vertex. It means in the complete bipartite graph, we don't have any vertex to it, hasn't any adjacents to other vertex. Has like this, for example, A, B, C, D, E, F, like this. For example, it is one other edge. This types of edge we don't have in the complete bipartite graph. Thanks for watching.